I work for Dan. Dan's the man, yeah, exactly. Easy joke. All right, let's get started. I don't know that they're going to fit many more people in this room. Oh, there's still a seat there and over there. Good afternoon, DerbyCon. That's good. I like that. I'm Sean Metcalf, and this is Red versus Blue, Modern Active Directory Attacks in Defense. I'm the CTO of Dan Solutions. Yes, I work for Dan. Company that provides Microsoft platform engineering and security solutions. One of about 100 Microsoft certified masters in Active Directory in the world. And I work with large enterprises to show them how to best secure their environment, specifically Active Directory. I do a lot of AD security research, results of which I put into these slides and I post to adsecurity.org. The agenda is straightforward. We have attack techniques for the red team and mitigation and detection methods for the blue team. So let's start with the red team. The red team. Well, maybe about 20 years ago, right? Let's update this for the modern red team. Better? So this is a post-exploitation talk. We need to assume breach in our modern networks, which means that the attacker has dropped some code running on your computer, a computer running on your network. This is the reality today. So this is a post-exploitation talk. It goes without saying. Other talks talk about the malware and how they get on and what they do. This is what happens once that happens. PowerShell. Anyone here not know what PowerShell is? I'd be surprised. So PowerSploit has been around for a couple years. A lot of really interesting tools in that toolkit. The ability to dump credentials using invoke Mimikatz, which effectively duplicates the functionality of the executable Mimikatz. And I've listed a couple of the more popular ones here. But Empire was released this past summer and wraps a lot of these tools and functions available across other scripts and toolkits into a pure PowerShell agent that injects into a process. Doesn't use PowerShell.exe, which means that if you're trying to track PowerShell attacks using PowerShell.exe, you're not going to see it. So, hacking with PowerShell. What does it look like? It doesn't look like that yet. Maybe Empire will be updated. I know, disappointing. It looks like this. We're getting there. So, PowerShell Empire wraps a lot of the deployment methods that attackers are using today. Macros, HTA, DLLs, etc. Including injecting the agent directly into processes, like LSAS. It's an interesting one. It can leverage the Power Tools Invoke PS Injector to inject the agent into these processes. And this is what the attackers are doing. This is what the red teams are doing. So if you're on the blue team, you want to understand what these tools are doing, how best to detect them. Because Empire is going to use a ton of different modules, from recon to credential theft and reuse and persistence and privilege escalation. Not today. Afterwards. Thank you. So recon, let's talk about recon. I feel like I'm about to read a Dr. Seuss story. This is great. So recon. The attackers want to know about the domain controllers that are in the domain and the environment. There's a lot of different ways to do this. But realistically, in the modern environment, the easiest way to discover all the domain controllers in the entire Active Directory forest is the last .NET command that you can run in PowerShell. Most of the domain controllers running in a modern network are global catalogs, as per best practices from Microsoft. So once we do that, what are we after? We're trying to find their privileged accounts. This typically involves recursive group membership, usually focused and targeting domain admins. But if you recursively enumerate administrators, that includes domain admins and gives you a bunch of other things. Or if you, as a red teamer, target the RDC denied replication groups, it includes those as well as any custom delegated groups. And so when you wanted to identify who the partner organizations are for this current organization that you're operating with or for or against, you want to discover who they work with, who they operate with. Of course, one of the best ways to do this for years has been enumerating trusts. But you can also enumerate and ask the domain controller for all of the contact objects in the forest. A contact object is a special type of object that is effectively an email address for an external organization that's not part of that Active Directory forest. So if I want to learn about who this company does business with and who these users email on a regular basis, if I enumerate all the contact objects and dump those email addresses and then look at those domains, I know exactly who they deal with. This is how attacks happen, identifying those partner organizations, compromising them to come in the back door. And then the best way to discover enterprise services in an environment is what I call spin scanning. This is enterprise service discovery without network port scanning. There's no need for us to target a subnet and scan through a whole bunch of different random ports. We can ask the domain controller, where are the SQL servers? What ports are they running on? And the domain controller says, here you go. A spin is a service principal name. It's required for Kerberos authentication to work for that Kerberos-enabled service. Without that service principal name, Kerberos doesn't work. So if we ask for that information, the domain controller is going to give it to us. Why? Because when a user accesses that service, they need to get a service ticket for that service. In order to get that service ticket, the domain controller needs to associate a service account with that Kerberos-enabled service, which is the service principal name. We can discover the SQL servers. We can find all the systems configured for RDP, all the ones configured for WinRM or PS remoting, because PS remoting rides on WinRM. But then it gets really interesting because we can discover if an organization is using FIM. What's FIM? FIM is typically deployed in very large enterprises in order to manage privileged accounts and groups. If you're not trying to find FIM, I highly recommend you do if you're a red teamer. There's also Exchange, SCCM, and SCOM. So we can spin scan for services. I wrote a script, put it up on GitHub, but there's a lot of tools that do this. By asking for all of the spins of a certain type or class, we can get from the domain controller information about those servers, including the domain, the server name, the port number, the service account that's associated with it. So that means we can spin scan for service accounts. So we can ask the domain controller, what are all the service accounts or all the user accounts in the domain that have a service principal name associated with them? And this will give us information about which service accounts are associated with which services. Well, that's nice, but what are we going to do with that? Last year on this stage, Tim Medine released Kerberos, which is pretty incredible because what it does is it does offline cracking of service tickets. It's brute forcing, but the nice thing about this for a red teamer is it does not require any admin rights, and you don't need to communicate with your target. So you spin scan for service accounts that are running for SQL or what have you, actual user accounts in the domain. You identify those, and then you run PowerShell, and you say, I would like service tickets for these specific spins. You get that. You can check to see if that service ticket is now in memory. As a user, you have access to your own memory space, your own tickets. So we can see in KList at the bottom there that, yes, this user has access to that service ticket for SQL. So then what we use is Mimikatz to save this to a file as a user, and then save this off to our Kali box in Azure AWS. And then we run the Kerberos Python script against it. Now, if we have a pretty sizable word list or some other method to crunch through those passwords, effectively, Kerberos uses Kerberos against it itself because that service ticket is encrypted with the password data for the service account associated with that spin. So Kerberos runs through and brute forces it, attempting to open that service ticket. If it can open it, then it knows it found the right password. Detecting this can be done using an IDS signature because in order for it to work, it has to use the encryption type RC4HMAC because that's the NTLM password hash encryption type. So we can create an IDS signature to look for that. But the best mitigation for this is make sure your service account passwords are greater than 25 characters. Because you do not want to have your service account be the one that leads to an entire domain compromise. I can probably guess what length the service accounts are for most of the organizations. How? Because the service account password length is directly proportional to whatever the minimum password is for that domain, right? If it's 10 characters, the service count probably is 10 characters. Does that make sense? No. We can also leverage the new features in Windows. So managed service accounts with 2008, group managed service accounts with 2012. Active Directory will manage those passwords for us already, and we don't have to worry about them. We'll make it 120 characters and random. Detection is difficult if you're looking at events, but like I said, you can create an IDS sig to look for it. So then we get into group policy preferences. Let me hear a big groan. Group policy preferences. Released in Server 2008. It was a great idea, a great opportunity for administrators because they could do a lot of things with group policy they couldn't do before. Prior to this, admins typically would have to buy a product to make group policy really work for them. So with group policy preferences, there were a number of things that it brought to the table, which were useful. Primary among this, change the local admin account password for a large number of workstations. Now an admin just needs to create a new group policy, apply it to an OU with hundreds or thousands of workstations. It applies and changes that password. Well, maybe the admin comes back around and sets it to a different password later on. Maybe they don't, but no judgment. Well, that data for that group policy preference is stored in an XML file, which is in sysvol. All authenticated users in Active Directory have access to sysvol. And that password is base 64 and AES 256-bit encrypted, which should be enough, except Microsoft published the AES private key on MSDN. This was realized in early 2012, and then Chris Campbell genned up a PowerShell tool to then identify and exploit it. It's part of PowerSploit. So all an attacker has to do as a domain user, again, that post-exploit scenario, assume breach, that attacker has code running on a system as that domain user. They can scan sysvol, look for these three, or there's a few other XML files, look for a cpassword attribute. That data, that random string of data after that cpassword attribute is the encrypted password. So all we have to use is the PowerSploit AES decrypt function, and we have that password. So the mitigation of this is install this patch on every computer that might open up Group Policy Manager, because that prevents the admins from actually putting passwords into Group Policy Preferences, into sysvol. And then after you do that patch, you have to go through and check to make sure that there's no more Group Policy Preference files that store those passwords. Microsoft has a script to scan for that in this KB article. It looks a lot like the PowerSploit script, but we're not going to talk about it. Detection, you could create an XML file, set access so that no one can access it, set the ACL so no one accesses it, and then set auditing on it. And if you get errors, maybe someone's scanning for it. Please don't do this anymore. This drives me crazy. Just about every organization I look at, I found a VBS script in sysvol that has a clear text password, and this script is still on Microsoft TechNet Gallery. I actually pulled this last week. So please, please, please stop putting passwords in sysvol. It's driving me crazy. And it's making things easier for the attackers. Because once they have that admin password for those hundreds or thousands of local admin accounts on workstations, all they have to do is use that account to jump from one workstation to another, to another, to another. Because the term local is a bit of a misnomer. That local account, if that admin account and password are the same across multiple systems, you can just use that credential to access them over the wire. So what do we do to fix this? Well, we can leverage Microsoft's Lapse tool, which was released earlier this year. I hear TrustedSec has an option, which makes sure that these local admin passwords change on a regular basis and that they're random. Each computer has a different password. The other part of this is deploying KB 287-1997, which is effectively a backport of security enhancements from Windows 8.1 and 2012 R2. This adds a local SID, so that way you can track an account on a system as a local account. You create a group policy, apply it to your OUs, and say local accounts cannot log in over the network. That will stop that lateral movement of that type. You also want to start investigating workstation-to-workstation restrictions. Does it make any sense that workstation over here can communicate with a workstation over here? Even better, does it make sense that any random workstation on a network can communicate with the finance system or the HR system or a back-end database that stores all the PII information for an organization or even the badging system? Well, once the attacker gets those local admin accounts, what are they going to do? They're going to run commands on remote systems. I have a few that are listed here, but effectively it's WMI, which Matt Graber and colleagues are going to talk about tomorrow, or it's WinRM, PowerShell remoting, which rides on WinRM. And what are they going to run? What do you run when you get on a system? Red Teamers, what do you run when you're on a system? How about Mimikatz? So Mimikatz provides the capability to dump credentials, dump Kerberos tickets, inject those credentials, forge Kerberos tickets, forge golden tickets, silver tickets, trust tickets, all sorts of tickets. This is what happens when it runs on a system. In order to run Mimikatz, the attacker needs to have admin rights or be a local system. Why? Because Mimikatz interacts with LSAS. LSAS is that protected process, or pseudo-protected process. At least it's protected in 2012 R2 when you flip the bit. But there's a protected memory space that LSAS owns where the credentials are stored once you log onto that Windows system. So if a user or an admin logs onto that system, their credentials are stored in LSAS, which means that Mimikatz can dump them. And what's really interesting is that if you have a service account that is used by a service on that system, and that service starts up, that service has to place that service account credential somewhere. It goes into LSAS. So if you have services that are running on workstations under the context of domain admins, whoever can own that workstation can own your domain. And you can probably notice that there's a clear text password for each of these, one that you can read. That's because up until Windows 8.1 and 2012 R2, the Windows developers decided that instead of prompting users for things like passwords, we just go ahead and store it, all sorts of different things, just in case we need them later on. And then finally in Windows 8.1 and 2012 R2, there's a way to stop that, and by default they don't store the password in a easily reversible format. I know it's improper to say it's clear text, but it effectively is. Now, the backport patch that I mentioned earlier, KB2871997, you can flip a registry key to prevent the older versions of Windows, Windows 7, 2008 R2, etc., from storing that, from actually generating that, keeping it in memory. So what happens next? The attacker gets admin rights on workstations, then they go after the domain. It's not necessary to get access to data, but it makes things easier, doesn't it? Sure, there's two primary methods to do this. Get access to the ntds.dit, that Active Directory database file, or have credentials that you've pulled off of a system. Maybe you've gotten a domain admin credential out of a service or using Mimikatz or out of Sysvol or somewhere else. Those are the two primary methods, and then at that point, the attacker can either dump that Active Directory database file and get the credentials out of it, or run something like DC Sync. All right, Sean, so you said that you can find the Active Directory database on the network. I don't believe you. They're there. DC backups, DC storage on your SAN, on your NAS. Virtual domain controllers, very popular. The bean counters like to make everything virtual because it's cheaper, right? It's easier to manage. But if your virtual administrators are not considered domain admins, you may be in for a tough day someday. Because a VMware admin has the ability to clone that virtual DC, copy down the storage files from that virtual DC, which includes the DIT and the registry keys, take it offline, crack them open, and then dump the credentials. And that virtual DC clone can just be deleted. And since it was never started up, there's no event logs in AD. There's nothing that flows to the SIM unless you're monitoring your virtual environment. Another option for an attacker is to run a tool that's built in, NTES-util, used by AD admins in order to create and install from MediaSet or an IFM. This is very useful for the AD admin because if you want to deploy a number of domain controllers, you can create the IFM set, which effectively takes a virtual snapshot of the DIT on that domain controller, as well as some registry keys that are necessary. Copy it over to a member server that they're promoting. And then when they run DC promo point to that file, it'll seed that Active Directory database for that new domain controller, so it doesn't have to copy all that data across the network from another domain controller. It's a lot quicker. But the problem is that that is the DIT, so that could be dumped. And a lot of times this member server where this file is placed in order to promote it to a domain controller is not protected at the same level as a domain controller would be. Or maybe an enterprising domain admin said, you know what, I'll put this on a share, so that makes it easier when we're going to promote a DC later. Because once they have that file, they own Active Directory. Kali plus impacket plus a DIT file and the reg key means you own the domain. Now we have hashes here. We have curve TGT, which means we can create golden tickets now, or we can just use the hashes. Well, we've heard about pass the hash. But over the pass the hash is even better because we can clear out all of those Kerberos encryption keys on that system for that user and inject that NTLM password hash. And then when we request the Kerberos ticket, guess what happens? That NTLM password hash is used to get that Kerberos ticket, effectively converting that NTLM password hash into Kerberos, and now the attacker can use Kerberos, which looks like pretty much everything else. So the mitigation, ultimately protect your admin credentials. Set all your admin accounts as sensitive and cannot be delegated. I talked about this at Black Hat, showing how unconstrained delegation can be used where a single server in your environment could be used to compromise your entire domain. Make sure that your admins only log on to specific systems like an admin workstation. If an admin types her credentials on a system and it's shared by users, or it has user type activities done on it like browsing, web browsing, email, etc., those credentials could be compromised. So we buy a tool from a vendor, and what's the first thing we're told that this service account needs? Come on. Domain admin, right? And what do? We go, okay. I want this functionality. It's time to push back on the vendors. Sorry, vendors. It's time to push back on the vendors because oftentimes the developers that work for the vendors are under a time crunch. They need to get the product working, so they test with what? Domain admins. So if someone tells you that this account needs domain admins, find out when. Maybe you just need it for initial install. Find out why. What are the rights that are really required? So last year in November, Microsoft had a major vulnerability with the way that Kerberos was handled on domain controllers. The domain controllers did not properly validate the PAC checksum on the Kerberos tickets. Now the PAC is the privilege attribute certificate, which contains the group membership for the user for that ticket. So this meant that a domain user could rewrite their ticket and effectively say within the ticket, I'm now a domain admin, pass it to the domain controller, and the domain controller go, okay. So you could own AD in 5 minutes. Gavin Millard with Tenable had this great analogy. A lot of people here traveled on a plane. You have a boarding pass. You take a Sharpie. You write pilot on it. You go up to get on the plane. You hand it to the flight attendant. They escort you into the cockpit and say, what would you like to drink, Captain, before we take off? That's bad. So about 2 weeks after this patch was released, PyCat dropped. This is a Python script written by Sylvia and Monet, which exploited this vulnerability once you had a domain user account, which I've already explained that's not difficult to get, spear phishing, web download, etc. Well, the way this works is it requests a TGT, that authentication ticket that you first get when you log on. But it says, I want a TGT with no PAC, no group membership. The DC says that's odd, but here you go. So then PyCat gets that TGT with no PAC. What it does next is it creates a forged PAC that says domain admin, enterprise admin, schema admin, etc. Signs that with that domain user account password data and sends both of them back to the domain controller, sends back that forged PAC as an authenticator along with that original TGT with no PAC, and says to the domain controller, I would like a TGS with no PAC. I want a service ticket with no PAC. The domain controller gets really confused and goes, I have no idea what's going on here. So I'm going to dump that TGT that you sent me. I'm going to create a brand new one. but you gave me an authenticator, which is a PAC, so I'm just going to put that into that TGT and send it back to you. Here you go. So now the attacker has a golden ticket, effectively, that is good for that vulnerable DC or any other DC in the environment that's not patched, which means that that ticket can be passed to Mimikatz or something else to own the domain through that vulnerable DC. Earlier this year, Benjamin Delpy released a tool as part of his Kekio toolkit that took this a step further. With PyKek, you have to know which one is vulnerable. And there's been some tools out there that go, all right, well, if a DC hasn't rebooted in this amount of time, then it's probably vulnerable. That made sense late last year, maybe not so much now. But it actually scans and finds a vulnerable DC, and once it finds it, it exploits it and gets that MS14068 golden ticket. And then it takes it one step further and goes, here's the golden ticket that you created for me. I would like a delegation ticket. And that delegation ticket now works across all DCs, even the patched DCs. So the mitigation is straightforward. Make sure you patch your domain controllers. Make sure that the server image, the server build, has this patch before you run DC promo. Make sure all your QA checks before you run DC promo include this PowerShell command at the bottom. And you can create an IDS signature looking for Kerberos AS request, that's that TGT request, and TGS requests, both containing include PAC as false. So let's talk about what happens when an attacker gets domain admin. There's an infinite number of things an attacker could do, but ultimately there's a finite number of pathways. This is what I call sneaky AD persistence tricks. The attacker has DA access for 5 minutes. Trust me, that's more than enough. I'm going to talk about the ones on the left. I talked about a couple of the ones on the right at DEF CON. So golden tickets. What's a golden ticket? It's a forged TGT. That forged authentication ticket that proves who you are to the domain controller for login. Well, if I have the current TGT password hash, which is what's used to sign that PAC, as well as that TGT, users can't open it, only the domain controllers can, I can create my own. And when I can create my own, I can be anyone I want to on the network. Even Bugs Bunny, who doesn't exist, who's a domain admin. But I still have to pass that to the domain controller to get service tickets to do things in the environment, to do things in the network, in the domain. There is a limitation of sorts, if you can call having full access to a domain a limitation. But in a multi-domain Active Directory environment, a forest, as it's called, if you have a golden ticket for a child domain, you cannot pass that golden ticket to other domains. Because it says, I'm a member of enterprise admins, but enterprise admins is not held in that child domain. It's held by the parent, the root, that first domain in the Active Directory forest. So I was doing some research on SID history in the May-June timeframe, and I reached out to Benjamin Delpy, who wrote Mimikatz, and I said, hey, Ben, can you add SID history to tickets for Mimikatz? And he said, sure. Why? He soon figured it out. Golden tickets are now more golden because when you add that SID history component to that golden ticket, if a child domain in the forest gets compromised, that golden ticket will now traverse those trust relationships with the other domains, and those other domains will trust the information in that SID history field saying that this account is a domain admin. I'm sorry, an enterprise admin. An enterprise admin is effectively a domain admin in every domain. Not actually, but close enough. So it's important to note that the forest is a security boundary within Active Directory, not the domain. So the fact that you can jump from domain to domain within an Active Directory forest should not be news. But if you're a red teamer, you love this. If you're a blue teamer, we'll talk about that later. Silver ticket. This is like the younger brother of the golden ticket. Nobody cares about silver tickets. I really like silver tickets. Why? Because there's no communication with the domain controller. A silver ticket is a forged service ticket, a TGS ticket, for a specific service running Kerberos on a server. Remember that service ticket is encrypted with the password data for the service account for that service. So we don't need to ask the domain controller for that information we've already created. We can create silver and golden tickets wherever we want once we have that password hash data. And then we just need to inject it on any computer on the network, not even a domain joined network computer. Well, what's interesting about a silver ticket is if we have the password hash data for a computer account, things get very interesting because there's a lot of different services that run under the context of the computer account in Windows. And the computer account password is changed by the computer. Now, on some sort of basis, there's a policy for the domain that says the computer account changes about every 30 days. But it's more of a guideline than a rule. Active Directory does not enforce this. A computer could have the same password for years. AD doesn't care. It's not going to kick it out. And an attacker can actually block this process from working by setting this reg key or setting a group policy. This group policy, you go, why would you ever want to do that? In VDI environments, this is often configured in order so that when that master image is spun up with the copies of VDI, they don't need to try to track what that computer password information is. This gets really fun if we've been able to compromise the domain and we have that domain controller computer account password hash. What can we do with a computer account password hash for a domain controller with a silver ticket? Well, we can create a silver ticket using that password data for that domain controller computer account. And we can target any service on that domain controller. We can target LDAP on that domain controller. Does anyone know why we might want to target LDAP? DC sync. If we create a silver ticket for a domain controller using the domain controller's password hash data and target the LDAP service, we can run Mimikatz DC sync against it. And we can pull the curb TTT account password hash. So that was pretty fun. Let's talk about another type of persistence, the admin SD holder object, which may be known to Active Directory admins. I don't think anyone else might even really know what this is, but it's a template object that exists in the system container within Active Directory. And that's all it is. It's a template object. It does nothing else. It holds security information, security apples. And there's a process on the PDC emulator that runs about every 60 minutes. And it enumerates some of the most privileged accounts and groups in the domain. And if that group membership, or I'm sorry, that security information does not match what's on the admin SD holder object, it restamps it. And it also stamps those objects so that they don't have security inheritance. And then it sets admin count to 1. So you can actually enumerate privileged accounts in an environment without group membership enumeration or group membership checking, because you can look for accounts that have admin count equals 1. Now, Windows never comes back and removes that or sets it to 0, so you might get some false positives. But without looking at any groups, if you can enumerate all the accounts in the domain or ask for all of the accounts in the domain that have admin count set to 1, you can find some interesting privilege accounts. Why? Because they're members of these groups, or they're these accounts. So what's really interesting about this whole process is if we have domain admin rights for a few minutes, we can change the default ACLs on that admin SD holder object, and the admin SD process will run, which means that we can alter those permissions to gain rights on all of these objects. So we will go ahead and delegate full control to a user object, or to a user to the admin SD holder object. And then about 60 minutes later, that gets stamped on every one of those protected objects, which means that this account now has full control on the domain admins group. And this user has no group membership. But this user can add another user to domain admins, and it works. So Mimikatz added DC sync. This was big, Vegas week. Soon after that, Delphi rolled it into Mimikatz. You can use Mimikatz DC sync to pull password data for domain accounts, including users, service accounts, computers, domain controllers. It uses the domain controller replication APIs and requires membership in domain admins, administrators, or the domain controller computer groups. So I was wondering, how could I run DC sync as a user? If I had domain admin rights for 5 minutes, how could I persist and give myself access to it? So I figured this out. At the root of the domain, you set the permissions for a regular user account to replicating directory changes all, replicating directory changes, and filtered set. Those are the rights that are needed, the only rights that are needed to run DC sync and pull all the password data. So the next question is, are there any accounts that already have these rights? Maybe. So I found a number of Microsoft articles that talks about setting replicating directory changes permission for FIM-type services, or directory replication services, some instances SharePoint. None of them say set all three, but we know that admins always use the minimum number of permissions, right? So it's possible there's a service account out there that has DC sync rights. So if we Kerberos that service account, curb TGT, administrator, which includes the password history for that account, which means that if we can crack these hashes, then we know what password strategy they use for that account. We can pull the domain controller account password data. So detecting this is difficult through logs, but there is a way to do it with an IDS signature. If you do keywords for DRS UAPI and DS get NC changes request, and you correlate this with the source IP not being a domain controller IP, anytime you see that, you know that that is bad. So at DEF CON, I talked about the DSRM account. This is the directory services restore account, or store mode account, that is configured on all domain controllers in the domain, and the password is set for it when the domain controller is first promoted. And I talked about how to leverage this to retain full admin access to the domain controller. It involves knowing the password or changing it and setting this reg key at the bottom to 102. What's interesting is this account is set at DC promo when the domain controller is promoted and forgotten about typically. There's no easy automated way to change this across every domain controller. And so what do you think the admins set their password to for DSRM? Maybe one of these? I know a lot of admins that love keyboard patterns. They're up here. So the DSRM account is a domain controller local admin account. And we can dump this using Mimikatz, because Mimikatz can dump the SAM credentials. Interestingly enough here, we dump it, and we see that it's RID 500 on this domain controller, which is the administrator account. And we have a password hash. What can we do with a password hash? Well, Benjamin Delpy and I were working through this last week, and we discovered something really, really interesting. We got very excited. He got very excited in French because he's in France, which is even more exciting. We couldn't pass the hash for the DSRM account. Fail. We got events that said we failed. 4625, fail. 4776, fail. We were very sad pandas. So yeah, I came up here to tell you I failed. So we thought about it. Can't pass the hash using the DSRM account. But what happens if we change that registry key, that DSRM admin logon registry key, which doesn't exist by default? Well, if you set it to 2, which is what admins do in order to log on with the DSRM account without having to shut down the AD service or rebooting. Boom! We were able to pass the hash using the DSRM account. We got access to the file system on that server, this domain controller, with that DSRM account. That's nice. But we were able to use DC sync. So using that local admin account, which the password is generally not changed, the reg key is often set to 2, we were able to run DC sync and pull the curb TGT account password hash. No one ever uses this account, but I ran DC sync with it. So I know the red team right now is ready to have a party, right? Lots of cool stuff. Right? That's fun. Haven't forgotten about your blue team. So there's a number of different things that you can do. Potentially there's anomalies in events for forged Kerberos tickets. DC Silver tickets, make sure that you change your computer account passwords after a breach. Object permissions, you want to check them on the admin SD holder, the root domain. IDS SIG for DC sync. Changing your DSRM password regularly. Monitoring that reg key and the DSRM events. But ultimately protecting your AD admins. So blue team, I have love for you too. So I know it feels like it's 300 versus 300,000 being a blue team, being a defensive person in the computer world. Rob Fuller threw this up recently and said, how many of you can fill this out? It's quite a gauntlet. I'm here to help. So if you have the Active Directory commandlets installed, you can run this command at the top, which will give you information to help fill out a lot of that computer data, including operating system data, looking at the types of operating systems. I have a cheat sheet here from MSDN. Operating system and then the version number, which is that family. And then you can do the same thing for users. You can get the information about the users that are out there. When their password last set, password never required, SID history information, which is often used for persistence, admin count, service principal name. But defense starts with logs, as InfoSec-T says. You need to make sure you're logging. If you're not logging the data, you're not going to get what you need to track an attack. So let's talk about PowerShell attack detection. It starts with logs, logging all PowerShell activity. Configure PowerShell module logging, so that way you can get the log data, that detailed log data. Who here went to Lee Holmes' session earlier? If you didn't, you want to check it out. Because there's a lot of really good information there that talks about PowerShell security, especially in PowerShell version 5. Now, once you're logging, you can look for interesting activity. There may be some legitimate PowerShell scripts that are downloading stuff via .NET or running invoke expression, although I know Chris Campbell would disagree with that. You can look for encoded command or bits activity, etc. But ultimately, it comes down to if you have PowerShell remoting on your network in your environment, make sure it's being used, because if it's not, disable it, because that's a great vector for an attacker to use once they have admin creds. You can limit PowerShell remoting to specific subnets, admin subnets, by configuring the WinRM listener. And you can audit and meter your PowerShell usage in your environment. So detecting invoke mimikatz using signatures, that's kind of a fail, right? Antivirus companies are doing this. It doesn't work. So I dug in a little further to look at what these commands are doing, the PowerShell attack tools, what they're actually doing. In order for them to work properly, they need certain .NET functionality, certain API calls. And so you can use some keywords to look for in your event logs, your PowerShell event logs that now you're pulling back. There's no guarantee that they'll be there, but if you see them, it can lead you down those breadcrumb trail to find out what's going on. And you can see in the event here, if I'm looking for token privileges, I can get some obvious events. If I look for something like system reflection, there's a ton of events. So I cracked open the PowerSploit GitHub area, and I looked at some of the commands there to see what similarities there were. There were a number of similarities, and it's not just PowerSploit, it's a number of other tools. Token impersonation, token privileges, system reflection, get GPP password, which scans for the scans sysvol for group policy preference passwords. And in PowerShell version 5, this all gets a lot easier. I'm sure you're thinking, all right, Sean, you can look for these keywords, but it could be obfuscated, and then you just never find it. This is very true. Again, it's about finding these breadcrumbs, setting yourself up as a blue team member to have better potential for success to detect the attack. So there's a number of great security enhancements in PowerShell version 5, which I heard is out sometime later this year. It starts with script block logging. So one of the most common methods by an attacker is to run an encoded command which has base64 encoded data, and when you module log that data with previous versions of PowerShell, you get the encrypted command. You then have to crack it open. PowerShell version 5 enabling script block logging gives you that actual deobfuscated command that was run in that script block. You get system-wide transcripts, which gives you an over-the-shoulder look at what people have been doing. This can be configured by group policy and saved to a write-only share on your network. And that way you can parse it later using a tool, SIM tool, or using scripts to see what was run, when it was run, who executed it, but what the host application was that ran it, which I think is very interesting. And then we talk about constrained PowerShell. Constrained PowerShell language mode boils PowerShell down to just the core. So all that advanced functionality that everyone loves, certainly the attackers love it, like API calls and .NET and everything else that don't work in constrained language mode. PowerShell version 5 locks down to this mode by default once you get app locker and allow mode deployed on the network and you have PowerShell version 5. And that can stop a lot of those attacks. The story gets better with Windows 10 when we're talking about the anti-malware scan interface, which means that before that PowerShell code executes, PowerShell kicks it over to the AMSI, which exposes that code to the anti-malware solution, and PowerShell will not run that code regardless of whether or not it was invoked from the internet or run from a script or typed in manually until it gets back a status OK. So let's cover some of the mitigation that I've mentioned and some that I haven't. Deploying KB2871997, you want to do this on every computer on your network. Set that group policy, leverage those local SIDs. You can look at RDP restricted admin mode. The client component is covered in this KB article. The server one is covered in these different KB articles depending on the OS. But ultimately it removes those credentials that log off, which didn't happen prior to this patch, at least in the down-level clients. And it will remove or prevent that clear text password from actually being stored in memory by setting this registry key to 0, which you have to do after installing the patch. And you want to monitor this reg key because attackers are actually setting it to 1 in some cases, so that way this clear text password is available in the newer versions of the Windows, including Windows 10. Now I've covered some of these just as an overview. Make sure you know who your admins are. Make sure there's no user accounts there. Good admin hygiene. Long complex passwords for your service accounts. Patching domain controllers. Randomizing those computer local admin account passwords. Additional protections for your service accounts. Making sure that you know what systems your admins are logging onto. Should be separate admin workstations. PowerShell logging. So now we get into what I call mitigation level 3, or the it's complicated level of difficulty. It's time to stop using domain admins, so that group should be empty. Domain admins is 1990s thinking. The NT days. The movie Hackers came out in 1990. It's time to stop using domain admins. How do we do this? We clear it out. We get our Exchange admins out of there. We get our SCCM admins out of there. We get our SQL service accounts out of there. We create custom delegation groups and we give them the rights they need, not the rights they ask for. We start looking at temporal group membership, which is going to be a feature in 2016, where we look at the fact that everyone is here. If you're a blue teamer, if you're a domain admin, if you're an admin, your admin account is back at your company, still with admin rights. It's time to reconsider that paradigm and start looking at a better way to do it. When we are not operating, when we are not using or performing tasks where we need these rights, we should not have those rights. There can be a workflow which when I come in, I go, I need these rights, and then it goes through a process. Maybe it's auto-approved, maybe it's a workflow that gets approved later. But the important thing is I get a notification that I requested it, and someone else does as well. Because if I get a notification email right now that says domain admins, I know that that's not me. And implement network segmentation. Target, after they were breached, hired a pen test team to come in to check out their environment. The pen test team discovered that they were able to compromise a meat scale at the deli counter at one Target store and use that to connect to the cash register at another Target store. It's time for us to stop making our networks so flat. It's time for us to start protecting our networks at the level we need to. I have a number of additional mitigations, the most important of which, make sure your computer accounts roll if you're in a breach recovery scenario. If you are in a breach recovery scenario, I'd love to talk to you. It's tough. Change the current TTT account password hash at least every year. It's got to be changed twice every year. And especially, or daily. You might have some application problems. And especially when an Active Directory admin leaves. And deploy internal IDS. If you're not watching the traffic inside your network, you have no idea what's going on. I can tell you what's going on if you don't have an internal IDS. So in summary, the attackers will get code running on a target system in your network. The extent of their access is entirely based on your defensive posture. And if your Active Directory admins are not protected at a very high level, they will compromise your entire domain. And part of this involves making sure that our AD admins only ever log on to domain controllers or special admin servers and special admin workstations. Same thing for server admins, only servers. Only workstation admins, only on workstations. Because once an attacker gets server creds, server admin creds, or domain admin creds, it's game over. By the way, I broke the meme generator. It's going for Chris Campbell's record. So that's been my time. Thank you very, very much for yours. I think we have another minute or so for questions. These are great references to follow, highly recommended. I have about 1 minute for questions. If not, I can go outside and talk with people if they have some additional questions. Thank you. Yeah. Yeah, the slides will be available on this link right here, adsecurity.org. I'll try to get them up this weekend.